and overseas. We take pride in delivering the most authentic, trusted, and up-to-date and timely information. These are some of the covers. Our digital presence is strong with the reach of more than 70,000 on various social media platforms. See Wow Construction World on WhatsApp. Just give a missed call to this number and get industry updates on the go. This is one of our latest offerings that provides you with the most exclusive information from the construction industry. You can start your free trial today. And with that, technologies like BIM Civil 3D enable the creation, management of digital representation of a project and how it can improve efficiency, reduce cost, and enhance collaboration among the construction team members. With the same theme, I now invite Mr. Abhishek Solanki to please join us and present a small case study on how Civil 3D and BIM has helped him in planning his project. Abhishek.
Hello.
Yeah, Abhishek.
Right. I will share my screen.
Yes, please.
Small case study from my side. From Magra to Baddi project. Can you see my screen, everybody?
Yes, we can.
So this is a small project we have done in Civil 3D. Magra is in near Chandigarh, Punjab, and Baddi is in this was a project of 12.5 kilometers, which was from totally hilly terrain. So it was a challenge to design in a hilly terrain. So we have used the BIM Civil 3D to do it. To make the all alignment along the hilly terrain. Here we use Civil 3D, and geolocation tool was very helpful for us to locate the exact location and to realignment, take a decision of realignment, whether from which side we have to realign it. So it was very helpful for us in Civil 3D, the geolocation tool. And basically the CAD background which we get in Civil 3D, that was very helpful.
Abhishek, I'm so sorry to interrupt. Your voice is a little low. If you can hold your mic a little closer so that.
Okay. Just 5 minutes, I will relocate me. Huh?
Uh, Abhishek, are you here?
Yeah.
Yeah.
Sorry for the interruption. That the meeting was there in that location, so I have to shift it to another location.
No problem. You can carry. Thank you.
So I was telling about the alignment. The challenge was there to design the alignment in the hilly terrain. So we have used the geolocation tool in the Civil 3D, which help us for so it was very helpful for us to design it. Secondly, the profile was simultaneously getting along with the alignment. So it was easy to take the decision to where the alignment is to be shifted, the hillside or valley side, because dynamically I can see my alignment and profile simultaneously. That was very helpful for me. The style we have developed in Civil 3D. For that, we have used all the tools. This was our final output in which we get all details of the profile, like proposed level, existing level, the right ground levels, elevations, horizontal bands, vertical bands, from the profile.
Abhishek, I am so sorry. You're still not audible clearly. I will do one thing. Let me switch on to the fireside chat and I will get back to you once that is done. Really sorry for the interruption. Let us move on to the fireside chat and we can roll back to Abhishek again. The fireside chat today, let's understand how technology plays an important role in improving efficiency, reducing costs, and enhancing collaboration among construction team members. I invite our moderator for the day, Mr. Nikhil Bagalkotkar, Director Technical Sales from Autodesk. With him, let me invite our speakers, Mr. Atul Bhobe, Managing Director, TPF Engineering. Mr. Bhobe has more than 33 years of experience in the field of bridge and structural engineering consultancy. As a member of various IRS committees, he is instrumental in regular updates made to the IRC codes. With that, I also invite Mr. Yogesh Desai, President and CEO, PrimaVerse. With over 24 years of experience, Mr. Desai has successfully led enterprising engineering services firm catering to the clients worldwide, including mature markets of North America. With the emergence of technology-aided approaches in every sphere of work, the prime focus of PrimaVerse is to be a one-stop shop for all the challenges you face with regard to computer-aided designs, that is CAD. With that, I invite all the three speakers and
Thank you, Prashant. I hope
yeah.
everybody is having a really fine afternoon, and I'm really excited and looking forward to the conversation that we're expecting to have today. We've got two stalwarts from the industry who've had a lot of claim towards delivering solutions and delivering projects, really, really large projects, not just on the design phase, but also throughout the consultancy and the construction phases of the project. So without taking a lot of time, let me start off with the opening question. And the opening question that I wanted to kind of throw open to both my panelists today is, what are some of the best practices or success stories that you can share with us about BIM and technology for road and highway projects? And can you share a few examples of how you've been able to leverage technology to deliver those?
Okay. So let me start by introducing. Thanks, Rushali, for an introduction. I have been doing this infrastructure work for global clients for last 21 years now. And I have been using the Civil 3D and the BIM softwares from their almost inception, like 2003, 2002. So coming back to the betterment of this BIM and what this is, in general, if you plan better, the work would go smoother. So it saves time, money, and everybody's efforts. In India, the most of the people think you can take a decision on site, which is not the correct way. Everything has to be planned before you go on to the construction of any object, not about only the roads part of it, but we'll stick to the roads. Now, with the technology that we have right now through Autodesk and various similar to Autodesk, we should not even think about it, what we can do with the technology available at the fingertips now. So what we need, we start with the surveyor. There we have a Civil 3D software that you can plot, drone, process the data. Similarly, after that, as the initial the webinar part, alignments, profiles, cut and fill sections, everything you can do it with the Civil 3D, and that helps you to build the what would actually see on the site. So you don't have any guesswork, any limitations, or any modification at later stage, and you create a record drawing accordingly. So my gut suggestion is use the technology, do it. And this week, coming back to one example, we travel abroad and we say the roads are better, infrastructure is better. They do the similar way like we do, only they follow the guidelines that we should do with the design, and we will have the similar infrastructure that we see in the Western countries. We are getting there with the current government, with Nitin Gadkari ji and everybody. We are seeing the better roads that we were seeing 20 years back, but there is scope for improvement. But yes, next 5 years, you'll see a lot of digital change with the road ahead, with Mumbai-Delhi road connecting, Nagpur-Mumbai connecting, Nagpur-Pune connecting. So that's going to be a huge infrastructure development. And technology, what you currently have, is very, very important role to play, including the BIM and Civil 3D.
Atulji, your perspective, your audio is not coming through.
Thank you. First of all, thanks, Rushali, for the introduction. Thanks, Nikhil, for the opportunity to speak. I would extend what Mr. Yogesh just said. BIM, we have been using BIM and AutoCAD right from their inception many, many years back. And even before AutoCAD came into picture, we were using software called RoboCAD. Many, many years ago, when I started my career, 86, 87, we used to do RoboCAD with a template, and you could use a tablet to pick up icons from that and so on. So I've seen the advent of the personal computer, I've seen the advent of AutoCAD, I've seen the advent of BIM, and corresponding design softwares as well over the years. But what is remarkable now is that you are able to do multidisciplinary work, and it's not just restricted to something like roads. Almost all infrastructure projects that we are now involved with, be it bridges, be it tunnels, be it station buildings, metro stations, metro viaducts, everything is now connected through BIM, especially when it is multidisciplinary and you have 5 consultants working on the same level of drawings. You have the architectural, structural, MEP, the HVAC, everybody working at the same time. So it becomes very, very easy to identify crucial bottlenecks in the planning stage itself, not even the planning, even the preliminary conceptual design stage itself. You don't need to get to a stage where you have to reduce beam depths at a later stage. You puncture beams just to pass a conduit and stuff like that, which used to be in the past. It's all gone. If you see the new station buildings that are coming up, let's say in Mumbai, Pune, Delhi, Agra, everywhere, almost all of them are using BIM to go from concept to completion all the way through. Talking about a case study, we just finished the Samruddhi Mahamarg. We did package 1 DPR, which is starting from Wardha and ending at Nagpur. And we did supervision of 2 packages, and these are fully BIM compliant projects, which means that the planning and design was done on BIM. When the contractor came in place, the planning and construction management was done through BIM. The contractor added his layer on top of the design layer, and the client MSRDC monitored it using BIM. So it was a wonderful experience of using BIM end to end, adding layers as the progress of the project showed up on screen as much as it showed up physically. So it was a wonderful experience using BIM.
Thank you, Atulji. Some very, very interesting insights, and I can't help but recap, right? Technology has helped create better plans that have been able to deliver better outcomes. We heard about both the stalwarts having used BIM and aligned technologies for more than 20 years now, it's amazing to have you and hear from your years and years and depth of experience that you carry. We also heard about removing guesswork from the site. That's what Yogeshji mentioned. And Atulji talked about as soon as we're seeing this emergence of multidisciplinary projects, roads, bridges, tunnels, viaducts, stations, and a project spans across all of these. That also enables a lot of different work streams to work on the same project. And using technology is the only way to identify and solve for these bottlenecks before they start manifesting themselves on the field. The next question, a slightly related question, is got to do with the pace of the infrastructure development that's happening. I'm based in Mumbai, and no matter which street of Mumbai you choose, you can see that there is some work happening. And a large portion of that is around infrastructure, could be around better managing stormwater drains, or could be around flyovers or the metro projects. So the next question was primarily around, we're setting new records around the pace of infrastructure development, not just in Mumbai, but across the entire subcontinent. In your perspective, what role has technology played in commissioning, designing, and construction of these projects?
Okay. So, as like Atul said, and we have heard, the technology plays very, very important part in everything. As you rightly mentioned, BIM. Different consultants working on a one common platform, BIM Collaborator Pro, will help make the life easier. So that's a designing, planning stage part of it. After that, you have to go on the field, do the survey using drone. It saves time. It gives you accuracy. Doing the analysis for the traffic studies, that gives you a lot of data. With the 2022 end, the Indian government is coming with a geospatial policy, new geospatial policy, which is national geospatial policy, which is going to digitize almost the India thing now, which is similar to US. You have it now. New materials are coming in either way, so it gets built faster, quicker, and more durable. Like I visited Nagpur a couple of weeks back, and they said on the Samruddhi Mahamarg there was a accident. So they said it was because of the person traveling with a higher speed than it was allocated. They could actually track what speed he was traveling after the accident happened. So with that technology, you are almost using to the fullest. So the technology plays very, very important role, but we should use it to make it the infrastructure go faster and make this as a developed country faster, because roads is going to get you more business and cut you the travel time. Like Mumbai, Delhi is cutting you 18 hours to 12 hours, which is commendable. The Nagpur Pune time was 15 hours. Now you can come down in 10 hours. So that's how the times are reduced. This is all because of the technology and the fast construction. I was part of Gammon India in my early start of career when the flyovers were constructed in Mumbai. I worked on specifically Mankur, Vashi flyover, and I remember MSRD had a scheme that time that if you complete 1 day in advance, you get 1 lakh rupees as a bonus. And if you delay by 1 day, you had 1 lakh, 1.5 lakh as a penalty. And you will not believe, with the technology, machinery, using the curb and the roads, Gammon could complete each bridge 3 months in advance, which they earned about 1 crore profit. And when the total cost of the project was 10 crores. So technology has a role to play. And without that, we cannot succeed, but it has to be done right way. And the faster they adopt, better for everybody.
So my take on technology in 3 phases of a project. If you start from the concept, go to the design and the tendering phase, because we work on public projects most of the time. And the 3rd phase is the construction. Of course, the 4th phase is operation and maintenance, but we are not talking of that. We are talking of the 3 phases that generally we go through. What we have found in the example that I mentioned of Samruddhi Mahamarg is that it helped that the 3 operative arms of the teams, and there were 3 different teams working on 3 different levels, used the same model to portray the same project right from conception all the way through to the operation and maintenance. That is remarkable. We never had technology like this before. So you had people who were doing it manually most of the time. And what Yogesh ji mentions about those flyovers, at that time you never had BIM, but of course you had AutoCAD, and you were doing drawings in AutoCAD, the 2D drawings in AutoCAD, you were doing the animations in 3D Max or 3D Studio, and so on. But the technology then was more what we call hardware related, which is upgradation of the construction facilities, technologies related to piling, ready-mix concrete, reinforced earth walls, pot bearings, precast beams. So many new things were tried at that time. But now what we are talking when we say technology is actually digital technology. We are not really talking about upgradation of construction hardware. Construction hardware is now more or less standard across the nation. The roads are getting better. So from the time, let's say we constructed the Mumbai-Pune Expressway, to the time that Mumbai-Delhi Expressway is being constructed, you will see a remarkable improvement in speed and quality of the work that is being done. And in both cases, it is technology that's playing a huge part. Coming to the 4th D of my life of a structure or a life of a project, the operation and maintenance and the tolling, which is going on the highways. The current bottlenecks of toll nakas that you face on national highways or Mumbai-Pune Expressway are due to disappear next year. That's a promise made by Honorable Minister at several forum that he speaks on. And 2 pilot projects are already in operation, where geospatial location of your vehicle will actually decide the point at which you enter the expressway or the highway and the point at which you exit, and you will be charged only for the distance you travel and not for the distance between the toll nakas. That is a huge improvement on what we do now. And that's possible only due to technology. This was not thinkable a couple of years back worldwide. It will be if the NHAI and the Ministry of Road Transport and Highway are able to implement this next year, it will be the first such implementation worldwide. And that's an amazing move for the country and for the software and the technology people who are behind all this in the country.
Thank you. Some amazing perspectives. We spoke about the 3 phases of the project and digital continuity across all of them. Taking this, what you had designed in the concept, using it for tendering, using the same for construction, and leveraging data to really improve not just speed, but also the quality of the projects being done. You also spoke about using BIM as a technology and how it's helped with things like traffic study. We spoke about the National Geospatial Policy and how it's going to transform the way we use our highways and road networks. And of course, Yogesh spoke about newer materials, how it's helping deliver projects faster, quicker, and more durable. So again, some amazing insights coming in. I'm sure the other folks on the call are also enjoying this perspective that you're bringing to the table. Aligned to this, and I remember Yogesh, you spoke a little bit about DPR, and I just wanted to bring uh, this as a discussion point. With the government mandating trainings for DPR creation to improve the quality of the DPRs and reduce the risks associated with project completion, I'm sure everybody in the industry is now really keen in terms of understanding what's your view on this move, and is there a role practices like BIM can play in this transition towards having more specific, more detailed DPRs?
This Atul can explain in detail in general because he looks after the construction. But what BIM can do is, yes, they'll play a role in the DPR for sure. Well, look at the DPR 10 years back and look at the DPR now. There is change, but there needs to be more change, more refinement. And for that, we need to use technology. Now, when we work with our clients globally, US, anywhere, we can do the estimation sitting here with the software, various softwares, include mainly the Autodesk, but it is PDFs, Bluebeams everywhere. Sitting here exactly and predict the amount of material that is required, the quantities required, takeoffs required, everything. So this part of study, similarly, the DPR will consist of traffic study. What will the people go? How much time will it require to construct? This everything can be planned in advance with the tools that you have. And BIM will play a very, very vital role in that. Because if you do the 3D models right, the excavation, earthwork, everything would work out correctly, and you know what the cost is. The cost doesn't go up. To give you the lighter side of it, I was working with a Kirloskar consultant way back in '99, and we were doing a Bajaj site, and the excavation was something like 5,000 cubic meter or something like that. By the end of the contract, it was like 20,000 cubic meter, because what the contractor did was pick up the excavation and put it in the new place. So you have to excavate again. So that's how they did that. But if you do it using the tools, right now we sit here and do like 80 acres, 1,000 acres quantity earthwork estimation work sitting here and doing the DPRs and takeoffs, sitting US, and as US or any other countries is legally bounded liability, we are not faced the same in last 10 years. So that the tools that we have really help. And that's the way to go, because it reduces human error going forward.
Atulji, your perspective?
I'm going to give you my answer in two parts. One is the question that you asked related to training of DPR personnel. My opinion has always been that skill development is the bottom line for all trades. It's not just related to BIM or for DPR or whatever. See, DPR incorporates a lot of skills. A DPR for a road is not just a highway engineer. There's a highway engineer, there's a pavement engineer, there's a quality management plan engineer, there's a structural engineer, there's an estimation. There's a lot of disciplines that are involved in a DPR. And to get to an accurate DPR, you need the boss, the project manager, to be able to get all of these together, bundle it, and be able to pitch it as a DPR. Now, what's missing in all these layers in creating DPRs is trained personnel. If you want a 100% accurate DPR, the first thing you need to do is to get 100% base data. Now, that in a lot of our experience in the past has always been that the base data itself is wrong. You pick up a lot of stuff from LiDAR these days, so your base data is accurate. Previously, when you used to do total stations, or even before that, when you used to use theodolites, your base data itself was wrong. So even if you used AutoCAD, you still made mistakes. And it was not 100% perfect. So all these comments that you hear about and inadequate training for DPR personnel is coming from the anxiety that the DPR that is being executed leads finally to a perfect estimate and to a perfect quotation by the contractor, so that everything is seamless. I think we are getting there very, very fast. The government of India is fully invested in skill development of personnel, and so are the industry members and other stakeholders. So I think, to answer your question flat out, my belief is that absolutely skill development is the bottom line. It has to be done. To answer your second part of the question, where you said, how does BIM or how does technology help in DPRs? I'll give you one example specifically. I'm sure there are a lot of people here who travel on the Mumbai-Pune Expressway. When you're traveling from Mumbai to Pune and you cross Kamshet, there is a 90-degree curve. When you cross Kamshet and turn right, there's a food court on the right side. You turn right to go towards Pune, and then there is an ascent which takes you into the first tunnel, the long tunnel. Now that tunnel in the original feasibility study carried out by Wrights, and remember this is as early as 1991, when you were doing physical survey using theodolites. That tunnel was almost 300 meters higher than what you see now. So when it came to revalidating that DPR and putting it to tender, we started thinking about lowering that tunnel so that the length would reduce. Original length was much more than what you see now because it was at a higher, I'm telling you the reverse thing. It was at a lower level. And so we moved it higher by 300 meters. So that reduced the length of the tunnel. And at that time, the cost of the tunnels was what was dictating the cost of the project. Tunneling was not so well known as it is now. These were one of the very, very early tunnels that highway engineering sort of did in India. That one move of moving that tunnel up and down, we spent 2.5 months just doing the alignments and profiles. Just imagine something that you do now in a couple of seconds. Any transportation engineer or highway engineer today sits on AutoCAD Civil 3D, takes a BIM software and simply moves one line and you have all the quantities with you just in a matter of seconds. It took us 2.5 to 3 months to come to the final alignment. What you now travel on is the final alignment that came about after 3 months of exercise, which was done manually at that time. But that one move saved us nearly 250 crores at that time in the cost. Today's cost, if you translate that cost, would probably be, 3,000 crores, I guess. 10 times that cost that you would do. So that's a live example of what happens when you have technology at your beck and call.
Amazing insights. 2.5 months coming down to minutes in a span of close to 20-30. 250 crores. That's very similar to the top line of many companies. So that's huge, right? And that goes directly to the bottom line. That's a saving. So we also heard some amazing insights on the need for skill development and why having a baseline skill when it comes to DPRs can really help us close the gap that we see in terms of accurate quantity takeoffs. Yogesh spoke about having a better hold on the analysis of traffic that would flow on those roads. And we also talked about one of the biggest killers, which is earthwork. We all know that gridding can be the difference between a profitable and a massively unprofitable project. And he spoke beautifully about how grading optimization was done in some of his projects. So some really, really interesting insights coming in. And knowing that I'm running short on time, I just got a prompt here. I want to probably switch out the last question and give the baton back to you. And if I were to ask this question, I'll ask it slightly differently. If you were granted a magic wish that would make a change to the Indian infrastructure space overnight, what would you wish for and how would that impact the industry?
It's a magic wish. It's tough to answer with the Indian context, but frankly speaking, I have traveled everywhere across the world over the last 10, 12 years, and I've seen how Western countries have developed. So we need to develop infrastructure to that level to become a developing country. That's the first thing. Now, how we do it comes from the top to bottom, everybody's responsibility. Doing the things right and getting it the process oriented, doing like as Atul said, even though they spend 3 months, if it saves 250 crores, do it right. Then maybe the DPR was wrong, but you don't follow that. You do your common sense, you do a logic before you take the decision. So coming down to again the magic wish, plan, execute, and then deliver. Don't start delivery without planning and executing. That's the very, very important thing. Like as we are running short of time, otherwise I would have shown for a 1 turn lane drawing that we did in the Western country or the force main extension, we have to do about 20 sets of drawings to make sure that it's done the force main extension, which is already existing. Because of all the liability issues, signage putting, everything. So for one force main extension, we have to put 19 set drawings to make sure that it is approved from the county. So we need to go to that level so that it is very, very systematic and nobody has a problem with what the work is going on. Anybody. That's what my wish is.
Thank you, Yogesh. Atulji, your
It's difficult to give you an answer about one magic wish. If I had one magic wish, I would wish for 100 more. That would be my magic. But anyway, just to answer your question in one line, I would say that if we were able to transform the civil engineering industry academic backgrounds of our engineers coming out of college, fresh out of college, if we are able to impart employable skills to our civil engineer, well, not just civil engineering, all
Everybody.
engineering students, yes, this applies across the board to all engineering students. I think the transformation that you're seeing in the nation will be accelerated 10,000 times. See, when I graduated in 1985, Mumbai had two engineering colleges, VJTI and SPC. You either got into one of these or you went to one of the capitation fee colleges in North Karnataka. That was the place to go, Manipal or somewhere. Or you didn't become an engineer, you did something else. Today, that time our batch was 40 people. So you had only 80 civil engineers coming out every year from Maharashtra. Not Maharashtra, from Mumbai area. Maharashtra, of course, had three more colleges at that time. Sangli, Walchand, Nagpur, VRC, and there was one more, I'm forgetting. There were three more colleges. So we didn't have like a lot. Yeah. So we didn't have like a lot of civil engineers coming out. So maybe you had like 300 engineers coming out of Maharashtra. And all these engineers learned on the job. But teaching 300 engineers at that time was probably an easy feat. Today, Maharashtra produces more than 60,000 civil engineers every year. So my magic wish is if suddenly 60,000 civil engineers become employable the day they walk out of college, I think we can transform the nation fantastically at a huge speed than what we are doing now.
Thank you.
Nikhil, I had one point to add what Atul said, and I completely agree with him. The curriculum of whatever our education has to change, and it has to be more practicable than what it is in theory. Like I employ about 100 employees right now, and the people that we hire, it's like, I don't care. It's basically you have to train from the scratch. So I am fighting with you guys, Autodesk guys, specifically to where we can do the civil 3D quality trainings. So it is that we have a people, but there are not enough trained people to the level that we should deliver. So that's very important. And it should be the trainings and education has to improve across all levels. All levels. I mean, not only engineering, but not only civil, everybody.
Thank you. I couldn't agree with you more. Having talent who is ready or aware of what's happening on the field today can really make the difference between going to market quicker and also closing the so-called infrastructure gap. And that's something that we'd love to partner with organizations like yourself, and we'll do our bit as with the academic institutions to try and see how we can definitely help make a lot of the products and technologies that we have accessible to educational institutes across the country. I would love to continue talking, Atulji and Yogeshji. This is such an interesting conversation. But in the interest of time, I wanted to just take a second and say thank you for sharing your perspective with us today. I'm very, very certain it was so much more engaging for everybody else on the panel and even for me. So thank you so much. And with that,
Thank you for having me.
Thank you for giving us the opportunity to open up about the civilness that we work in.
thank you, Atulji. Thank you, Yogeshji. With that, I will hand over to the next presenter, Prabhu. Over to you, Prabhu.
Thank you, Nikhil. So This is going to be in continuation to what we were discussing in the fireside chat, where we discuss about how Autodesk technology can actually help in the delivery of a road and highway project. And when we mean by project delivery of a road and highway projects, we're not sticking to one phase or one stage of a project. We're going to talk about how this can help you in all the stages, such as even if you're in a DPR preparation stage or the detailed design phase, construction or the operation phase. So how will Autodesk solutions help you in all of these different phases? And we will look at these in two different perspectives. One is in terms of design efficiency, and this is what we spoke during the fireside chat as well, where we spoke about how technology can help save time, reduce cost, reduce the schedule. We heard stories where there were savings of about 250 crores and all that. Right? So that is design efficiency. We'll see how Autodesk solutions can help you improve the design efficiency of your projects and therefore increase your business outcomes. In addition to that, we'll also have a look at it in the perspective of safety. And why is safety important? Safety is important because in 2020 alone, the country reported 132,000 fatalities due to road accidents. There can be a lot of reasons for this, but poor road engineering is also one of the major causes of these accidents. And as designers, as engineers, we also have a responsibility in designing safe roads. With 3D modeling tools such as Autodesk Civil 3D and the Autodesk AEC collection, there are ways by which some of the hotspots in these roads and highways can be identified at an incredibly early stage during the design of highways. By incorporating Autodesk technology in your projects, you can not only create an efficient design and construction that will improve your business outcome, but also create safe designs that will ultimately save the life of people. So let's see how. So if you take any road and highway project, it has multiple phases. And for each phases like plan, design, build, and operate, there are multiple milestones that we need to achieve in each of these phases. So starting with the planning phase, two major milestones that we have in this phase are purpose and need study and alternatives analysis. Purpose and need is where the owners and planners evaluate traffic needs, assess environmentally sensitive areas, develop alternatives for design. And the alternatives analysis will help determine the preferred alignment based on all the factors like environmental impact, asset performance, public need, cost benefit ratios, etc. So let's take a simple example of how this works using Autodesk technology. So this is InfraWorks, and in this roadway example, you see there's a two-lane road connecting a highway interchange to a major subdivision, and it needs to be expanded due to demand. So the owners and the planners would use the traffic simulator that is built into InfraWorks as part of the purpose and need study to understand and study the area. They could also identify environmentally sensitive areas and include them in the study to aid in the alternative analysis, whether they want to do the alignment across this location or they want to bypass the alignment to a different path. So this is what you can do in InfraWorks, and all of this can be optimized as well. Like if you want to optimize your corridors, or if you want to optimize your profiles, that can be done. And all of these different alternatives designs can be stored and accessed using the cloud platform called Autodesk Docs. And anyone with the project access permissions can view these models in the cloud, in the ACC viewer, in Autodesk Construction Cloud Viewer. What this means is you don't even have to have InfraWorks installed on your system to just review the model or look through the model. You can just open the file that has been put by a designer on the cloud and review it. Diving into the design phase, the design team pulls GIS data to better picture existing conditions. So the more information they have about existing conditions, the better and the final design and the final road or highway project that you have. So we all know that it is easy to create surfaces inside of Civil 3D, where you can import points, or there are multiple ways to create surfaces in Civil 3D. You can import points and easily convert them into surfaces. And what's more interesting is how you can use these surfaces instead of Civil 3D to run analysis so that you can use it for safety procedures as well. So what happens is it is important in some cases to analyze the slopes on the road surface and identify flat spots on the road that could lead to waterlogging. What Civil 3D does is it helps you analyze the surface and see the results visually. What you see here is a slope direction analysis done on the entire surface. But imagine you can do this on your road surface or your corridor surface as well and identify flat spots easily. So this slope direction analysis in Civil 3D, what it does is it places a slope arrow at each triangle centroid of the surface. And the arrow color is based on the color assigned to the slope range. So you can assign different colors to different slope ranges. And when at a location, if all the arrows point to a single direction, it means that there's a flat spot on that particular corridor surface, and you can rectify that immediately so that you enhance safety and also make it better for the road user in the ultimate state. And what if you don't have any data? You can still use, if you don't have survey data from the site, you can still use more modern methods of survey like LiDAR scanning so that you get a point cloud data of your entire site. Those data can be brought into InfraWorks and Civil 3D. And the good thing here is that once you bring in that data, it can also be extracted. So let's say you have an existing road and you want to extract the center line of the road, the right of way of the road, and create a surface out of that. It is possible using InfraWorks and Civil 3D within the Autodesk tools. So where you can export or extract the existing conditions and bring them back into Civil 3D, where you can develop a surface out of it and then do further detailed design on top of it. And when we talk about existing conditions, GIS is a major player here. So using the Autodesk connector for ArcGIS within Civil 3D or InfraWorks, you can compile data layers that can be added to Civil 3D, whether you want to add utility data from GIS providers, or you want to add existing road, or you want to add existing buildings or land use patterns, anything that is available in the ArcGIS database, you can bring them into Civil 3D and view them here directly on top of Civil 3D so that you get a better idea about the existing conditions of your project. Moving on to the detailed design part. So this is where the team starts to develop the plans, the specifications, and the estimations for your project. And Civil 3D gives you a hoping productivity improvement in this space when you compare it with AutoCAD. So if you just look at this, we commissioned a study that explored the productivity differentiations between AutoCAD and Civil 3D when performing the same civil engineering workflows like surface creation, alignment for your road projects, creating your profiles, grading your site, and also producing your schedules. Results show that Civil 3D could allow a user to complete a task up to 20 times faster. So you can see the time difference here compared to AutoCAD. And how this is done is because of the dynamic framework that Civil 3D has between alignments, profiles, and every component that you see inside of Civil 3D. So you can do detailed geometric design for both horizontal as well as vertical design components inside of Civil 3D, where you can draw the alignments, and the alignments can be dynamically linked to profiles. And you can, any changes here can be, any changes to the surface will also affect the profile automatically. So you don't have to go back and forth and do changes. And when we talk about assemblies that you want to apply, like cross sections that you want to apply to your corridors, these roadway assemblies are built into Civil 3D. You can calculate the earthwork quantities and they are displayed directly in your cross section diagrams. And from this, you have a dynamic relationship between all the different components. And then you can also run certain automation on top of this. Like if you want to place lamps, light poles along the entire alignment, you don't have to do it manually. You can specify an alignment, and using a Dynamo script, you can automatically place the alignment and also drive through the entire corridor to see how it looks and feels. And once the initial design is done, when you think there's a need for a bridge or an elevated corridor, InfraWorks makes it easier for you to do that as well. Wherein, let's say we have this particular portion of road here, and this is a very high embankment, and we want to convert this into a bridge component. All you have to do is select the start station and the end station, and it will be automatically converted into a bridge in InfraWorks. You can choose the type of piers, you can choose the type of piles, the pile caps, and you can also type the choice of girders that you want to use in this project. And all of this can be brought back into Revit, where you can do more detailed design in terms of designing the reinforcements for these components. So see, all of these different components are interlinked. So any changes that I do here will be automatically, you can sync those changes back into another tool, since all of these tools are interlinked with each other. And finally, you can create sheets, either plan sheets or profile sheets, both in Civil 3D and in Revit. And one more thing that we added recently is the ability to support IFC 4.3. So IFC 4.3 is a new IFC framework specifically for infrastructure projects. And Civil 3D has the ability to export your road models directly into an IFC file. And the IFC file can be opened in any neutral IFC viewer, or you can also open them in Revit. And the advantage of opening them in Revit is that you can select individual components now. You can see the properties of all the individual components, and you can also create detailed drawings. Like if I want to create a cross section, which is really easy to do in Revit, I can do cross sections for the entire corridor here. Earlier, it used to be just a solid, but now you can go into the refined elements and you can see each and every individual element, and which helps you tag and annotate them also easily. In addition to this, what you already see in Civil 3D, the built-in capabilities in Civil 3D. We also have something called the India Country Kit for Civil 3D, which was developed specifically for India. The country kit is helpful because it contains road design standards, point styles, coordinate setups that relate and much more related to India in the Indian context. So you don't have to do all of this on your own. You don't have to do anything from scratch. You can just pick and choose whatever is available in the templates that we provide you in the country kit, which can be downloaded and installed from the website for free of cost and use it. So the standards, these are the standards that we have included in the country kit. And just to give you an example, this covers both the safety aspects as well as the design efficiency aspect. One thing that the country kit helps you do is have road design criteria based on Indian standards. So the criteria-based design, it provides the ability to verify your alignment or profile design if it meets the IRC standards, right? So we have incorporated all the IRC standards here, and these criteria are available to you if you install the country kit, and you can check the design criteria for minimum radius for a given speed, attainment method, super elevation calculations, minimum transition length for a given radius. And if the design parameters are exceeded, so if you do your design and the software finds that your design parameters are exceeded, it doesn't meet the criteria, it will automatically throw you an error that will tell you that this does not meet the IRC design guidelines, and you can reiterate your designs based on that. We have also included a lot of sub-assemblies based on different types of roads that are available in the IRC manuals, like IRC 73 or IRC 84, expressways, 4-lane, 6-lane roads. All these assemblies are already built in for you. You don't have to create them from scratch. Just have to select the ones that you want to use and apply that to your corridor so that you can have those cross sections immediately. And these are some of the assemblies that we have for roads, for tunnels, for metro rails, and all that. And we also have some road safety markings. They're also important in terms of safety because they provide the necessary information and warn the users of potential dangers, thereby safeguarding the vehicle user and the pedestrians. These signs and markings can be identified and incorporated early into the design with Civil 3D so that they are not missed during the construction. So you can do this right when you're designing the project. The India Country Kit for Civil 3D provides a library of lane markings and road signs based on the IRC 67 to help this cause. And they are multi-view blocks, which means they work in both 2D as well as in 3D, as you see here. And when designing critical curves in a highway, it is really important to analyze and incorporate vehicle maneuvers into the design. How will my vehicle be able to take this curve? The geometric design that you do must also cater to the critical vehicle which governs the radius or width of pavement, clearances, etc. For example, in India, the Indian Road Congress suggests that for important roads, the largest vehicles such as single unit truck, a semi-trailer, or full trailer combination will govern. So with Autodesk vehicle tracking, you can access a global vehicle library, which can be used to evaluate the movement of state vehicles, lightweight vehicles, and even aircrafts if that is of importance to you. In addition, you can also determine best parking layouts and explore alternative solutions. So you can do a sweep path analysis, do a side distance analysis of the vehicles, and also run animations in 3D so that it clearly tells you how a vehicle would actually maneuver through the road that you just designed. And with the country kit, we've also included a host of Indian vehicles in the library, like buses, trucks that are used in India, and you can use them directly for your design aspects as well. Moving on to the design review part. One important thing that I want to highlight is that if you have been using Navisworks, you'd be happy to know that alignments are now supported in Navisworks. So earlier, if you had to review a civil engineering road project, you used to do it in Civil 3D, which would be really difficult because the file would be really heavy and it would be really slow. You can open those Civil 3D files now in Navisworks directly and review your alignments directly in Navisworks without the need to open Civil 3D and do that. So these alignments are now supported. The review of alignments is now supported directly in Navisworks itself. And now that we've moved to the completed the design part, next is the model conditioning part where you can take quantity takeoffs easily. So any component that you have instead of Civil 3D, you can assign pay items to those entities. Like if you want to take off the quantity of asphalt that you have used in your road, or if you want to take off the total length of curb in your road, or if you want to take the total quantity of subbase in your road. So all of those can be pay items can be assigned directly to the sub assemblies, and you can generate quantities like this for your entire project. And these are dynamically updated. So anytime you make a change to your project, all these components are also updated to match those changes. So you can take off the quantity, and this can be exported into Excel sheets, any formats that you want. Moving on to the constructability review. With Autodesk Construction Cloud, it gives you the ability to do automatic clash detection on the cloud itself. So if your models are placed on the cloud, it will automatically detect for clashes and give you the clashes that are there in the model. So for example, let's say now here there's a utility line that is clashing with the light pole. This clash will be automatically identified by the cloud platform. And then you can create an issue and assign it to someone from your team. What they would do is they'd go back to the Civil 3D model, easily find out what the issue is and make sure that the changes are done and update the model back to the cloud. And you can also see the changes. And it also allows you to run a logistic simulation on top of it, where you can bring in your schedule on top of your civil infrastructure project and see the timeline of how it will be actually constructed on the site based on your actual schedule of the project. Next up is field execution, where we can, once the design is done and we are up to the execution part of your project, when the contractor is executing it on site, the cloud application can also be accessed using tablets or mobile phones, wherein you can open the drawings directly from the site. You don't have to call the site team, call the design team and do anything. You can open it directly from the site, take photos of the site. And if you want to create RFIs, you can create those RFIs directly from the site itself. And the design team will look through the RFIs again, and they can either submit an official response to the RFIs or close the RFIs, or add videos or attach the latest file so that this RFI is aptly promptly answered for your EC progress. And it also helps in the closeout phase, where the contractor can provide an as-built data from the field and note the changes on the drawing. So for example, in this case, the contractor is actually adding a guardrail and end treatment that was left out of the design files. So they can use the markup functionalities within the cloud environment to propose what they want to change. And this can be communicated back to the design team, where they can make the changes in the model. And the same changes can be done on the site as well. And once the changes are done on the site, photographs from the site can be placed within the cloud environment so that you can review it. So, and you can also save that as an as-built drawing. So the field engineer sees an issue, marks it up. The issue automatically goes back to the design team. The design team updates their model, and whatever updates have been done on the model goes back to the field team so that they can incorporate it on the site. And that is also tracked here. So the entire history of that particular project is tracked in one environment. And in the final phase of operations, the owner has access to all the documents and the aggregated model created by the design team and the contractor. Specific asset data, property set details, everything is available to them. And you can also publish this data back to ArcGIS so that you can have it on the JS servers. And you can create a walkthrough of the entire model. Once everything is complete, you can view and bring in all the components of the model into one interface, where you can see the entire model along with buildings associated with it, along with the structures associated with it, like tunnels or bridges, and have them in one view so that you can visualize the entire project in one environment. So using all of these tools, Autodesk will help you in all these different workflows that you typically have in a road and highway project. So whatever you see on this picture, everything can be done using the Autodesk solutions, and all of these models can be saved directly on the cloud so that you have seamless access anywhere based on the permission, based on the security that you provide. And that's how we provide design efficiency as well as safety. We help you incorporate design efficiency and safety in your projects right from the design stage itself. Irrespective of which stage of the project you're in, starting from the DPR or detailed design or construction stage, you can use these tools, use this technology from Autodesk to incorporate efficiencies in your design and construction, as well as safe design, so that we can save lives of people when you actually construct the project. Thank you. Back to you, Vishal.
Thank you, Prabhu. It's pretty clear that the road ahead is indeed digital. And before we actually sign off, let me share my screen. Some upcoming events from construction world. We just saw that how technology is helpful in saving the overall cost. How it is, important to accelerate our projects that are there. And our upcoming event, Construction Technology Summit, will definitely highlight on such points. It is happening on 14th of July at New Delhi, and some of the other events that we are hosting. If there are any questions, please feel free to share them with us right now. All our speakers are here, and you can paste your questions on the chat or Q&A text box, and they are here to take them up.
And also, if I may put in a shameless plug, we have Autodesk University coming up in the next few months. We are expecting 10,000 people from all across the world congregating on the largest conference on architecture, engineering, and construction. So we would love to have anybody on the panel from India or anybody in the audience from India participate in Autodesk University through your papers. So in case you want to apply or put in your papers, we'd love to work with you to present at a global platform. And that will also be a great way to showcase some of the work you've done and showcase the capabilities of your company and your industry. So back to you, Prashali. Sorry for the shameless plug.
No problem. I have also shared the LinkedIn profiles of Nikhil and Prabhu on the chat. If anyone wants to get in touch with them, you can get in touch with them directly. And any other question? I do not see any questions. So with that, I think we come to the close of today's webinar. Thank you to our esteemed panelists, to our audience. Okay, I can see one question. Nikhil, will you be able to take it up? How effective is this in quality control area?
So absolutely, it is one big challenge that many of us in the industry faces, translating what was designed to what was constructed. And there are multiple workflows that technology, by having a BIM model, what that allows you to do is it allows you to bring together or digitize many workflows, including workflows like uh, checklists for quality, checklists for safety, ensuring that there's a continuous communication channel open between the design team, which is in the head office, and the site team who's working on the construction site through things like markups, issues, RFIs, the whole lot. And that what that ensures is that you're up to spec every time. And more importantly, there is also a lot of accountability across all the stakeholders that are involved in a project. We had some discussions on multiple work streams kind of converging to deliver multidisciplinary projects. And that's what having a complete end-to-end digital story helps, where we're translating concept as what was designed during concept stage, we're translating the same into detailed design, tendering, quantity takeoffs. The same thing then goes into construction, and the same thing can potentially go into the O&M stage as well through a digital twin kind of a model.
Nikhil, there is one more question pertaining to Civil 3D. What are the system configuration that are required for Civil 3D? If you can answer that as well.
You just pull that up.
And there is one more, if it is in congregation, how do you do gap analysis between software data and actual site data?
So there are multiple ways. So let me answer the first one. The second one,
Okay.
for the meantime, while
Okay.
I put the specs. The second one, there are multiple ways in which customers have done this in the past. There have been instances where LiDAR data or point cloud data has been overlaid onto the BIM model to understand deviations. Also had a few of our customers in India who've used LiDAR data to do things like payouts for their contractors and subcontractors, so that is in line with the actual progress on site. Uh, while LiDAR is not the only answer, we've also seen photogrammetry being used, because on sites you can't necessarily have a totem station or a LiDAR device travel with you every time. So we've had these tools that we've built in, which is called as a photogrammetry tool, where you just take your phone, click a whole bunch of photos, and then it'll stitch it together to create a digital model, which can then be overlaid on top of the the design model, and you can come to know the actual progress and deviation. So multiple.
Can this be customized per project or? Okay.
Yes, it can be integrated into a particular project's workflow as well. So the configuration is.
I put it on the chat.
Oh, all right. Awesome.
Okay.
8 GB
Thank
RAM,
you.
2.5 gigahertz processor, and around 16 gigabytes of disk space is what is needed, and a display card with 1 GB capacity. But it is also highly dependent on the size of the model that you're looking at. If you're looking at a really, really high level of detail, large model, the specifications needed might go.
Thank you so much. These are all the questions. We will be able to share more updates on this. Let me just confirm. Yes, these are all the questions we have. We will share the specs and the other links that Prabhu has put into as a mailer with all the panel attendees who are there right now, so that they can go through it. And if there are any more questions, they can connect with Nikhil and Prabhu directly. I have also pasted their LinkedIn IDs on the chat. So if you want to connect with them, please do connect with them directly. Thank you so much, Nikhil. Thank you so much, all the panel members. Thank you to our audience we had a really insightful, engaging session. And now we are sure that BIM and Civil 3D technology are becoming essential tools for modern construction and engineering industry. We hope that this discussion has been informative and enlightening for you all, and look forward to continued advancement and applications of technology in our future. On behalf of Construction World and Autodesk, we thank you again for your participation and your contributions. Thank you. Have a